Welcome back to the channel. This is the third step of the in-floor heat project. So the first one was installing all the heat sheet product. That was the foam board with the nodules so you can run the tubing through. If you haven't checked any of these videos out, we'll leave links down in the description below. The second video was installing the Oil Creek plastics. So everything was all engineered and laid out by Thermo Supplies, our local distributor here in Pennsylvania. The third step is before we pour concrete, is you tie this manifold in and you put this whole system on test, 40 PSI, and make sure it obviously holds the test before you pour concrete. If there's any issues with a rock or something or some defect in the pipe, you want to make sure you resolve that before you pour the concrete. So we're going to do this project on this remote manifold here. This is for over in the great room. Since we have 27-foot high ceilings, Thermo Supply suggested that we put that on its own zone. So there's 4 loops in here, 1 zone. So you can see the 4 here, 4 feeds, 4 returns. So I'm going to go into a detailed video on how to hook up these manifolds, and then we're going to put this whole system on test, and hopefully it all holds. So stick around. So first things first is you want to get this manifold straight and hung on the wall. So I just put 2 screws to hold it in place just to get something hanging up there so I had a target to run these pipes to. But now I'm going to get it straight, level, and it has a total of 4 anchor points. So I'm going to put a level on there. That's pretty good there. So now that I got that level, and once the house is built, the walls, interior walls, this is just a template for me. So once I get the concrete poured, I stand the walls up, then I'll refasten this to the permanent wall, you know. So this is just something for right now for the concrete to be poured. All right, so that's all fastened in here. So now these tubings, so there's 4 loops here, so it's gonna be a feed and return, so a total of 8 pipes. So we're gonna determine which ones are feeds and which one are returns. So you always want to put the heat to the outside wall first. So I know this is going to be a feed because this runs to the outside loop. We did that first. And then this is going to run to that outside loop. So this is going to be a feed here. This is going to be a return. So I'm going to mark that on these conduits down here with a marker just so I can keep track. It's color coded up here. So it says right on here, red is a supply. So these are flow valves. These indicate the flow of how much liquid goes through these loops. So you can turn them in. Everything is all by hand. You can't use wrenches on this. You know, it's not designed. It's all designed to be done by hand. You turn everything in and out. When you air test, you obviously want them open. And then these right here are flow indicators. So you pull this cap off, and there's very detailed instructions that come in this box. And I'll put a picture up here real quick to show you what it looked like when I opened it. Everything was packaged very, very nicely. Well put together. It's well engineered out. It's very, you know, rugged material. It's got a chrome finish on it. So it's designed to last. But these are flow indicators. And then you open them up, and it says right in the directions not to open them up too much. I believe it's no more than 2.5 turns. And then whenever you fire the system up, you indicate the flow going through that particular loop because you want to maintain a certain gallons per minute. It has a flow gauge on there. So that's how you determine that. But that will be for a later video down the road whenever we fire the system up. For right now, our main goal is to air test this whole system. So we're going to hook all these up, and I'm going to show you how to do that without coming up short. You know, this is why you keep the manifold higher. So if there's ever an issue, you have room for air. You can lower it. So you want to try to just make sure, measure twice, cut once. So I'm just going to put an F on there and an R, just for a feed and return. So we're going to pull all these loops out for right now. I had them up in here just for when we were running it yesterday. And make sure you don't kink it. You've got to take this stuff out very, very easy so it doesn't damage it. All right, so we got all the pipes out of the way. So you want to work on one pipe at a time and one loop at a time. So you got to make sure that you got these two going through here. I could see that these are the feed and returns, but a trick is you could blow through it. So that confirms it, but I could see it here in the layout. Some guys don't do this step until after the concrete's poured. Then you do have to blow through it to determine the feed and return. So I've never used this particular kind here. So it comes in a 2-pack and it has an O-ring with a taper on it. You slide this nut down over top of here. Then there's this crush ring here. This is all like a compression around this barb fitting, and then that goes up through with an O-ring here. So this is where you got to pay attention when you cut this, because you don't want to preload it too much and have, you know, it buckling, but you don't want to come up short. So I put one of these nubs in here just to see how far that goes in whenever it's completely seated. So I'm gonna just do a little trial run here, get a marker, and I'm gonna cut it to the face of these threads here. So I took these dust caps off. They put these on there so dirt and stuff don't get on, and they're on there pretty good. So they're not gonna fall off in transport, that's for sure. So here's where I'm cutting this pipe to this finished face, and then it's gonna preload the pipe about a 1/16 of an inch. So then that way you know that you're gonna have enough going up. So just gonna take this over here. I could put this one up inside there to get even closer. So I'm gonna mark it there. Get yourself a pair of shears. Make sure it's a nice square cut. So now you want to pop this out of there. That was just a trial run. So now moving forward, I know I'm going to cut all these. I don't have to put that in every time. So you're going to make sure that this nut's on first. Then this crush O-ring, you got to get that on there. And then you push this barb fitting down through. Make sure it's seated all the way. Actually recesses up in there a little bit. Then you stick it like that. Bring your nut up through here. Now I got a little bit of preload tension on there. It's just as simple as that. Now you tighten this up. You don't want to over tighten it too, because, you know, it's just plastic and it's just an O-ring in there. So I believe the directions have it pretty in detailed on the tightening specs. So once it seats, it says don't tighten it no more than a half turn. So we're gonna go with that for right now. So it's just as simple as that. So now I'll do that same procedure on the return side. And then we'll continue this all the way down through. And then once we get all these in, I will put the ends on, and then we'll put the air test to it. All right, so you can see after the time lapse, it's pretty much repetitious work. So once you get the hang of it, it goes fairly quick. So that was 4 loops in probably less than 10 minutes. So it went pretty quick. So now we're gonna start putting the ends on, and we're gonna get some air to it for test. So what's nice about this manifold is everything's color coded. So hot's your supply. This goes in here. So this is like a union, and everything's has gaskets. So you put these spuds in here, and then here's the same thing for your return. And there's temperature gauges, so you can see what your feed temperature is and your return temperature. So it's pretty nice to know where you stand, and especially when you can tell if you're getting flow through a zone. So it's very in detailed to maximize, you know, to get the proper heat to the slab without having hot and cold spots. And then on this end, they have these purge points. So this is a bleeder, And then this has a hose bib connection on it, so you can purge the fluid through and drain it. That's how you get the air out. So it's pretty in thought process that they have here. So putting all this together, these have unions to break them. So unfortunately, this side here, I had to take 4 screws off and pull it out. It wasn't a big deal. I didn't want this stuff on here in the beginning anyways, because when I was setting this, people were working overhead and I was trying to minimize things getting broke. That's why I didn't build the whole manifold and set it up. So moving forward, if I was doing this project again, I'd probably pre-build everything as long as I knew it was going to be safe. But these bleeders, everything is all intact here. 2 places to put hoses in here. And then what happens when air goes up in there is a float. Whenever the air goes in there, the float drops and lets the air out. You can open these up. So that's some of the way to keep the system running throughout the season, is it purges its own air through there. So we're gonna put these on, and then I'm gonna throw some air to it and test it out. So we're supplied with these testing mechanisms. It's 1-inch IPS thread. That's what size this manifold is 1 inch. So I'm going to try to use this Dewalt air compressor to pump this up. I don't know if it's capable of doing it. That is a lot of volume of pipe, but I seen one of these. Guy was using it on a job, and man, it was really cool. If you ever seen one of these or are interested in buying one, I'll leave a link down in the description to purchase one. The little I did use it, it's been super handy. So just hook that on there. Make sure all these valves are closed except for this one. That's going to feed that manifold. And then make sure all these are open. And then we should be able to put the air to it here. So turn this on. It has a blower part for filling up inner tubes, or you can do air pressure. So currently it's on air pressure, and then you set it to where you want in this dial. So they recommend a 40-pound PSI. When this is operating, it'll operate probably somewhere around 12 PSI, because it's just a volume of water moving. It's not necessarily a pressure thing. So I have it on 40, and then it's going to hit the button here. So there you go, we're on test. Hit the power button. Shows you exactly how much is in there. So 40.4 PSI. The gauge is right on 40, so this Dewalt air compressor was pretty impressive. I set it to where I wanted and I walked away. I actually put a timer on it just to see, and it was right around 6 minutes to air pressure this whole thing. So this thing's definitely capable of filling up a big truck tire as well. So don't forget, there's a link in the description if you guys are interested in it. It's a pretty impressive piece of equipment here. So back to these Legend manifolds. Everything's holding. I'm very pleased. The one, I forgot to tighten one of these. It was hissing a little bit, so I tightened it down. Like I said, this system will never run at 40 PSI, so this is pretty much 4 times the operating pressure. For every foot you raise water, you need a half a pound of pressure. So since this is going to be in the ground, this system would operate on probably 5 pounds and be completely fine. So I'll leave this gauge on there, and then we'll double check it the day they pour concrete. Now, if they pour all this concrete and then I check that gauge and something's wrong, someone punctured it by accident. So that's some of the reason why you want to do all this, so you can make sure that you understand before and after, if there's an issue, where it transpired. So we're gonna take this off here and we'll leave this one in place. All right, guys, there you go. We have it on test. Everything's holding, so everything went according to plan. So I appreciate you guys watching. We'll catch you on the next one. Take care.